Many of us will have experienced the munchies after using cannabis. If not personally, you're probably familiar with the movie Harold and Kumar Go to White Castle. So it's universally known that cannabis drives the munchies through increasing food cravings and the motivation to eat. However, we don't actually know how cannabis causes the munchies, and if regularly having the munchies influences our daily eating habits and overall metabolic health. Now, this is extremely surprising considering the recent legalization of medical and recreational cannabis use in many parts of the world, including Canada. So with the global use of cannabis progressively increasing, there is an urgent drive to determine whether cannabis use is associated with metabolic health effects. So I'm Catherine Hume, a postdoc in the Cumming School of Medicine, and my research uses translational animal models to assess if the munchies disrupts normal daily eating habits. In short, my experiments consist of exposing rats to cannabis vapor, giving them different foods, and measuring their eating patterns. I specifically look at the effects of cannabis vapor, as inhalation, either by smoking or vaping, is the most common way by which cannabis is used globally. So far, I have found that the munchies occurs in the first hour after cannabis exposure, and that in this time, cannabis increases food intake as well as increasing the preference for high-fat food when given a food choice. Also, no matter what foods are eaten after cannabis exposure, having the munchies once a day does not increase the total amount eaten on a daily basis. Therefore, having the munchies may not cause overeating as such, but may influence food choice, which could have significant health effects if the foods eaten are unhealthy and are high in fat. Furthermore, rats who have just eaten their fill are still able to get the munchies, demonstrating that cannabis is able to disrupt the body's natural mechanisms that control appetite. So my next aim is to determine how cannabis interferes with these mechanisms, specifically whether cannabis acts directly through the brain, or whether it disrupts the release of appetite-controlling hormones from the stomach. Overall, my findings will support human study data and provide additional mechanistic insight that cannot be gained from human studies alone. Thereby, my research has significant implications for assessing whether cannabis use is associated with metabolic health effects, information which is vital for the well-being of recreational and medical cannabis users.